we ended our discussion on the topic here at saying water is weird, right? So let me just write these things down to actually tell you that how objects behave. Okay? Now here I'll be telling you guys on how it actually behaves. So most objects how they behave. Okay? It contrasts when cooled. Okay? Density is higher as temperature is lower. And this over here, it means rho. We talked about it in our fundamental physics. Now when temperature goes down, it shrinks, so the volume shrinks as well. So let me just draw a graph on how it basically looks when the object is basically shrinking when the density is high. Okay, so this is a graph. This we know is density, temperature, right? So basically it's at this point over here, and when you cool it, shrinks, it's going in negative slope. Okay? Now, what you are trying to say is that the frozen liquid sinks because we can say that we use the black marker, the density of solid, okay, is always greater than density of liquid. Okay? And that's for the most objects. And you guys can hear sounds, like I told you. Now, when the water is basically why the water is weird. And this here we talked about most of the objects. Okay, now let's talk about the water. Why water is weird. We actually said why water is weird. Now let's write things down to actually understand briefly on why water is weird. And I will give you some few real life examples, okay, to actually understand what we are talking about. So water. Okay, now water basically, and this is an important part, so I'll be zooming in and I want you guys to write it down along with me. Okay, so water is basically, it contrasts when cooled, okay, like every other object, but, okay, then expands near the freezing point. Okay, contrast when it's cool and it's being expanding near the freezing point. Okay, that's really weird. Okay, now it's really incredible, different, and it's unique. So this part over here that I will highlight with the red marker, it's basically unique when you are trying to cool down stuff. Okay, when the temperature is getting low. Okay, you're subtracting heat from it. Now, how would this look like in our graph? Well, basically, you have a graph, right? Density, temperature. And it basically goes up until it reaches the freezing point, which is this one. Let's consider this one. And then it goes down. Okay? So for H2O, which is water, ice floats. Okay, ice floats because the density of ice is always less than the density of liquid. Okay, now how is it amazing? It's just that it's plain cool. Okay, it's plain cool, because if it weren't the way it is, then all those lakes out there in California and Flagstaff, okay, all those lakes out there in winter, it would freeze and the ice would go down as it freezes. So you have let me show you how it actually works in this board over here. Okay, so what I'm talking about is I could also explain this while I'm talking, but I'll I believe in visual so you guys can really understand what I'm actually talking. So basically what's happening is that you have a lake over here, and whenever this water in winter, okay, whenever it freezes, it would form ice, as you all know. So you have probably seen the ice in movies or something like that. So what happens if it weren't like this, then the ice would form and then go down. Ice would form and then go down. Ice would form and go down. Eventually, what happens is the lake will be full of ice. No water would be in it. And if nature didn't exist like this, that's what it would happen. Okay? It behaved everything out. If water behaved everything out, there will be such what happens is if let's consider if there is no water over here, okay? If there is soft drinks of like say Coca-Cola, Pepsi, or anything liquid types, all of the lakes, okay, the streams would freeze in winter time, like we know, okay? As soon as the top layer is frozen, everything would sink down, okay? Ice would not float. And you may have seen in the movie, what's it called? Some movie, okay? They're actually floating on ice, piece of ice. They're using the piece of ice as a source of a boat to travel from one place to another place with a short amount of place, okay? So they can. All I'm trying to make a point here is that ice wouldn't float if the nature didn't exist like this, okay? Because the ice sunk already. Now, if the nature didn't exist like this, when the ice sunks, now, so new layer is formed every single time when it sinks down. Because when ice is formed, the ice goes down and the water under it comes up, right? So whenever you let's take fill a glass of water and put an ice cube into it. Now, it would float, right? But if the nature wouldn't exist like this, what happens is the ice would go down and the water comes up, as you guys can see. Or the best example is that when you don't take ice, instead of ice, take some heavy objects such as a needle, okay? Anything which you can think of, okay? When it sinks, the water comes up, okay? Rocks. The best example is rocks. I hope you have heard of the story, the crow and the water, something like that. That the water is this much and the bottle is this much. What happens is the crow puts rocks into it and the water comes up, right? So what happens is the rocks go down, okay? If it were ice, it would float, okay? So what happens is the water comes up and the ice goes down, right? So the upper layer of water becomes ice and it goes down. And it goes down again and again. Eventually, the lake or the streams would be frozen and it would be full of solid block of ice because of what I explained just right now. Now, in real life, it is whatever a lake gets cold, top layer of ice freezes, but the ice floats stays the same. Okay, the ice floating on it stays the same.